Adding on some complexity here, 2 coins are tossed. What is the probability of getting heads and tails in that order? So this is the same tree diagram as before, and it's asking what will get you heads and tails in that order. So we can't have anything from this one because that's tails first. So as I pointed out, you have your heads first and then tails. So that is 1 out of 4. Out of the 4 possible outcomes, getting heads and then tails is only one. There's only one probability, one chance. 2 coins are tossed. So what is the probability of getting tails and tails? We're going down here, and of course, we're going to the tails down here. Now, my line has been put in incorrectly, but you get the point. 1 out of 4. 2 dice are rolled. Here is a grid of all the possible outcomes. We've done this before previously, listing all of the possible outcomes. This could also be done in a tree diagram, but that might take you a different length of time. It would be a big tree to draw. And when we're looking at probability, we also look at the order, right? Because when we roll a 2 and a 3, or a 2 and a 3, this one you roll the 3 with dice number 1, then a 2 with dice number 2, and vice versa. So that can be something of importance. As we previously have discussed, there are 36 possible outcomes. Now we have a grid to list the possible outcomes of the colors on 2 spinners. Spinner number 1 are 4 colors, and spinner number 2 down here. So we always use the codes, as we kind of touched on earlier. R and R for red. RR, RY, RB, RG. So total number of outcomes, you can count up the grid, gives you 16. You can also multiply 4 times 4, which gives you 16. Of colors on a spinner and a dice. So we have our 4 colors, red, blue, yellow, and green. And so if I spin a red one, I will have 6 different options for rolling the dice, and this goes on. Because blue, I still have the same 6 options, same with yellow and with green. So you can count up all of the ends of the branches, or as you've listed them out, and you will end up with 24 possible outcomes. I like to personally count up the edges of the branches. In this case, you can go 6 times 4 to get 24. We know that based on our previous tree diagram that we should get the same outcome of 24, just like we did in time. In elapsed time, we showed you the number line and the t-chart, and both get you the same answer. It's good to practice both, but pick the one that you find works and is most comfortable for you. So I have listed out all the possible outcomes. I can count them all up. I can also go 6 times 1, 2, 3, 4, get 24 possible outcomes.